I'm going to ask for three things. Can we show that a particle whose motion is governed by this equation, can we show that it's simple harmonic motion? Okay. Secondly, can we find its sort of important statistics, namely its center of motion, how frequently it moves in simple harmonic motion, how frequently it oscillates, and can we find its amplitude? Okay, how far it moves back and forth. Lastly, can we find where, at what position, is it moving at half its maximum speed? Okay, at what place, or places really, is it moving at 50% of how fast it can possibly go? So, let's start this off, shall we? How do I show that it's simple harmonic motion? Now, because this topic has so many different equations, it's kind of like, where do I start, right? Now, I've kind of given you a clue already because of how we introduced this. If I want to show that something's simple harmonic motion, I've got these two options. Okay, if I can show, it'll be one or the other. Okay, so I need to get something to do with acceleration and something to do with x. Okay, does that make sense? So when you think about this, one of these being my goal, okay, what I've got is v squared. I've got to get from v squared to something to do with acceleration. So which equation helps us do that? Yeah, good. This is going to be the half v squared one, right? So I'll start over here. This is part A. I'm going to say, well, look, I know what x double dot is in terms of v squared. Namely, it's the derivative of half v squared. Okay? Derivative with respect to x. Okay? So therefore, since I know exactly what v squared is, I just have to divide it by 2 and then differentiate, right? So just to make sure I don't skip any steps, divide everything by 2, that'll give me minus x squared on 2 plus 7x on 2 minus 6. Okay? Alright, differentiate. Minus x squared on 2 becomes minus x, right? 7x on 2 is just going to become 7 on 2, 3.5. Okay, so I've differentiated. Now hold on a second. What did I want to show again? I wanted to show simple harmonic motion, right? So looking at these two here, which does it look like it's going to be? I've got a constant flying over here, right? So it looks to me like it's going to be this. It's not a simple, they're not just proportional to each other, okay? I've been moved off a little bit. Now, this is not quite enough. I'm almost there. I've got to show it's in this form, okay? So I'm going to rewrite this in a factorized form to make it really obvious, okay? So I'm going to put a minus out the front. Now, I want an n squared, right? So that n squared will come from the coefficient of x, which in this case is just 1. So even though it's a little bit redundant, but I'm going to write it as minus 1 squared. That's my n, okay? Then I've got x, and because I took a minus sign out, this changes over here. So just watch out for your signs, okay? All right, that's it. That's the equation I need. So I can say, which is in the form that I just quoted over there, right? Therefore, it's simple harmonic motion. Okay? I mean, getting to this kind of point is a bit like saying, I get to a form like this, so therefore, it must be a circle. Okay? Same idea. Once I get the equation in a certain pattern, that's sufficient. So there's part A.